All right, everybody put get well, Jasmine. No, don't say it. Comment it. Okay, got to write this down. There are three main categories, and this will be on your quiz tomorrow. There are three main categories of elements on the periodic table: metals, metalloids, and nonmetals. Metals are solid and they're brittle. What does brittle mean? Does it mean it's weak? No. Okay, rocks can be brittle, diamonds can be brittle, quartz can be brittle. It means if you hit it, it's going to shatter. Brittle. If you can see it, take a picture of it and zoom in. Solids, metals, one. Malleable means they can do what? Bend, right, Tyrell? Ductile means you can draw it into a wire. Metals are good conductors. That is why we use them in conducting electricity, and they have high melting points. Okay? Metalloids. Metalloids are solids. They're brittle, which means they can break, and they're semiconductors. Now, what semiconductors mean? They're okay at conducting electricity. Not as quite as ideal as metals, but still pretty good. And they have high melting points. Example, silicon. Here I have a chip board, a computer chip board, okay? And it's green, and it also has little metal things and black things. Guys, those are little transistors, and they're microchips. The little black things are microchips. Why would you want to make a microchip out of silicon? Think about that, Dylan. If you made all of this circuit board out of metal, why would it need this fan? Yeah, to cool it down, because these things get hot when they have all that electricity running through there, right? So if you made the whole thing out of metal, what would start to happen to the little circuits? They'd melt. So silicon is a better material for that because it has a high heat capacity, but it also conducts electricity. Yes, Margaret? Okay. So I will pass this around. Again, you have little transistors, capacitors, microchips. The circuit board itself, I'm pretty sure, Ryan will correct me if I'm wrong, it's made of silicon dioxide. The board itself, is that glass? Is it silicon dioxide? Okay. These used to be the size of rooms because before robots were invented, humans had to make the circuits, and humans we can't see or make as small circuits as robots, but now they're smaller. That's what's inside your phone, yes. Well, because your hard drive, your little hard drive in your phone is magnetic. So it's glass-based? Fiberglass, okay. All right, nonmetals. Nonmetals. Okay, those elements are solids, liquids, and gases. They're poor conductors, and they have low melting points. All right, obviously, Dylan, they have low melting points because some of them are liquids and gases, right? Okay, now, everybody look at the thing on the wall, the periodic table elements on the wall. So just pause for a second, look over there, Janaya. Do you see all the elements listed in black? All the ones listed in black are solids. Do you see any ones listed in blue? Which two are listed in blue? Mercury and bromine. Those are liquids. All the rest of them are listed in red. What does that mean? They're gases. Okay, so to the right of the metalloids, the staircase, you have black, blue, and red. You have solids, liquids, and gases. But everything to the left of the staircase is black. That means it's a solid. Okay? You talking about the staircase itself? Okay, the letters that are white are actually synthetically made elements, and some of them with the UUUs are undiscovered. If you look at your giant periodic table that's on your desk, you can see at the very bottom that there are some of them that say undiscovered or UUU. That means we don't have enough of them made yet to call them a name. Now, synthetic elements are things that are man-made, okay, and they're made in one of those either by chemical reactions or they're made in one of those big giant super colliders. Super collider. What it is, it's like a NASCAR track for physics, okay? And it's a big magnetized tube that takes two protons and smashes them together. Or it will take an element and smash them together and just see what you get. Okay? That's exactly what it does. It explodes. You just don't use very much of it so that you don't destroy the place. But you want to see what happens during that explosion. Do you create more elements, new ones? Do you create neutrons? Do you create antimatter? Things like that. Okay? Okay, Riley? All right, so this is the three broad categories of elements, and you need to know the characteristics of them for the quiz. Yes? No, Luis? No puedes? Posible? Okay. Now go to this, guys. Oh, not me. Hey, look, it's the infinity screen again. Disappear into the infinity. All righty. Now, look at the top here of your periodic table, please. Do you see where it says valence electrons? Right here, it says valence electrons. Okay, so as I was telling Lillian earlier, the Bohr model of the atom doesn't tell you anything about valence electrons. And valence electrons are very important because over here it says they're lost or shared in chemical bonds, and they're the farthest away from the nucleus. So Dylan, hello, see that definition on the board? Did you write it down? Everybody write down that definition of valence electrons. Okay, they are the ones that are farthest away from the nucleus, and they are the ones that do actual chemical bonds. They're very important. Now, if you notice, all the alkali metals column, okay, it has how many valence electrons? One. They all have one. One valence electron. Again, what is a valence electron? It's the ones that are lost or shared in chemical bonds. So when an atom goes to do something, it does it with its valence electrons. Okay. Target in the alkali earth metals, how many does it have? It has two. It has two valence electrons. What are valence electrons? Once again, Dylan, lost or shared chemical bonds furthest away from the nucleus. Okay. What about these middle transition metals? How many do they have, Amani? Generally speaking, they have two. Okay. Okay. Now, Janaya, check this out. Group 13 right here, this column, starting with boron. It has three valence electrons. What about the column that starts with carbon? How many does it have? Four. What about the one that starts with nitrogen? Five. The one that starts with oxygen? Six. The one that starts with halogens? Seven. And the noble gases? Eight. But one more thing here, Anthony. You see helium right here? Helium only has two valence electrons. Okay? Two valence electrons. Why? Because it's too small to have eight. It's just too small. So, did you write that down? Hello? Okay, well, I'll just talk to myself then. Two valence electrons. Good thing I'm giving myself a quiz tomorrow. So helium has two valence electrons. Don't write that down, Caitlin. Yeah, don't write it down. Or do write it down. Okay, next thing. I want you to take a pencil, and I want you to write fluorine right there. That's the element fluorine. And then I want you to go to the lower left, and I want you to write cesium and francium. Cesium and francium. Okay, they're going to be extremely important. Valence electrons, man. Oh, cesium and francium, and they're the lowest in the lower left-hand corner. Cesium and francium, and then on the upper right here you have fluorine and helium. Okay. CS, yes, it's a CS. CS for cesium. FR for francium. Yes, mine. Oh, we're not even close. We're not ready for that yet. No, ma'am. Those have to do with electron orbitals. And electron orbitals are totally different from the Bohr model of the atom, okay? You teach the Bohr model of the atom to high schoolers first, because it's simple. These S's, P's, and D letters, they're not simple. Okay, they have to do with the modern version of the atom. You guys remember when I said I would never quiz you on elements and symbols? But there are many secrets behind the secrets that you have to know. Okay, so tomorrow, am I going to ask you properties of metals, metalloids, and nonmetals? Yes, I am. Yes, I am. Do you have to know what a valence electron is? Yes. Okay, so what we're going to do now is I'm going to stop. That's all I'm going to share for live. We're going to start the, it's a worksheet of the periodic table, but your quiz tomorrow is on protons, electrons, neutrons, average atomic mass with the percentages. You remember that, Dylan? Vaguely? Somewhat? What about you, Riley? You remember it? Okay. Yes. Review the people. And then also this, and also how does an electron create light? Okay, somebody repeat that back to me. What's on the quiz tomorrow? People, what else? Average atomic mass, what else? Protons, electrons, neutrons, what else? Characteristics of metals, nonmetals, metalloids, what else? How electrons make light. Okay? Now, I have included, right here in Google Classroom, Chapter 5. If I was you, I would read those pages on Chapter 5. Margaret, I don't know why you're packing your things away. We still have class. We're still going to do more. There you go, assuming. And you can comment to yourself on YouTube and wave to yourself. Take your Chromebook back out because we got stuff to do on it. All right, dudes. I want you to click this thing that says Intro to the Periodic Table, please. I want you to click on that. It says Organizing Atoms and Electrons. Come on, Dylan. What are you doing, man? It's dead. Well, go where you need to go, man. Find a plug. You got a charger? Yes. Why is it called the periodic table? Why did Mendeleev call it the periodic table? Because properties occur periodically. All right? And what that means is to be periodic, it means you have a pattern. Okay? List 2 examples of phenomena that occur periodically. Well, types of elements in the same group. All right? Another example that you'll learn later is you have atomic radius. That's another trend. That's another pattern. What's an element? The simplest form of what? Simplest form of matter. Type that in there, Caitlin. Properties of metals and nonmetals. Well, you guys had them on the board. Okay. All right, so those are the first 3 questions. What I'm going to do now is these questions go along with this presentation. Crap. This presentation here, it says Organizing Atoms and Electrons. See that? Okay. So if you click on that link, it takes you there. And that's what we're going to start now, okay? So you all who missed class, like Jasmine, you can click on this thing. End of stream. Hey, that was a 15-minute stream, Riley. What do you think of that?